So this is the Poiseuille's equation. Q is the volume flow rate. Volume flow rate means volume divided by time, meters per second, cubic meters per second. This equation you must remember, right? This is a somewhat complicated equation, but you must remember this. They don't give you this in the exam, right? A to the power 4 delta P 8 eta L. So this equation, Poiseuille's equation, you must remember. Right. Today I'll discuss a new theory. Just write the topic, subtopic. Write down pipe series, sorry, pipe systems in series. This is a subtopic, pipe systems in series. Take it down. I want you to engage, right? Use the chat box if you have any issues. Right. So using Poiseuille's equation, we discussed how the volume flow rate through one pipe, right? One thin horizontal pipe. In this case, we connect two pipes or more, right? First, I'll discuss about two pipes in series. In series means like this, right? Not parallel like this. So the pipes are connected like this. Let's say this is a one pipe and another pipe. So they are connected like this. This is the in series connection. First take this down. Then I'll explain. Write down when a liquid flows through a series pipe system, when a liquid flows when a liquid flows through a series pipe system, series dash pipe system, comma, Q is same for each pipe. Q is same for each pipe. Below that, write separately, consider a system in series, which has two pipes, right? Okay. Now listen. So this is one pipe, right? These are thin pipes actually. Then what do? You connect another pipe here to the end of this pipe. Let's say this is the another pipe. Okay. This pipe has a radius A1. This is not area, this is not cross-sectional area, right? This is radius of the pipe, first pipe. Then A2 is the radius of the second pipe. And you have a liquid which has a viscous coefficient eta. And length of this pipe is L1. This pipe is L2. 2. Okay. And the pressures, let's say pressure here is P1, pressure here is P2, and P1 is larger than P2. Okay. So what did I say in the first sentence? If you consider the flow rate, let's say per second 5 cubic meters of, let's say, water flows through this pipe. Through this pipe also it is 5 cubic meters per second, right? You learn that in Bernoulli's, when you are learning Bernoulli, you learn that, right? What do we call that? The volume flow rate is same through the both pipes. Because if there's a 5 cubic meter flow, through this also it should be 5 cubic meters, right? If it is 1 cubic meter, through this also it should be 5 cubic meters. Whatever goes through this pipe must go through this pipe as well at the same flow rate. That is what we call AV constant. Remember, this is area, V is velocity. Area times velocity is a constant. So AV means flow rate, right? Remember? For flow rate, volume flow rate, you can use AV. So since cross-sectional area has decreased at here, velocity increases, having the same flow rate throughout the pipe. Okay. Just take this down and thumbs up. Just take everything, thumbs up, right? Right. Below that, right, simple A. Below this, right, simple A. Finding. So this is one type of questions you get, right? So I'll give you that as a theory part. Simple A. Write down. Finding pressure within brackets capital P. Pressure here. Finding pressure within brackets capital P at junction means this one, right? At junction when Q is unknown. Finding pressure P at junction when Q is unknown, right? So this is when you get a question from this, you might want to find the pressure here. These pressures are given, pressures at the ends are given, right? You have to find the pressure at this junction, right? Here, it has a different pressure. So how do we do that? Just apply, you know that Q here and Q here is the same. So for Q here, you can apply Bernoulli's equation. What is that? 5 over 8. A1, right? A1. Delta P. What is delta P? Delta P for this pipe, right? What is the pressure difference? This pressure is high, right? P1 minus P. That's the pressure difference. Divided by length of that pipe. L1. This is the volume flow rate through this pipe. And that volume flow rate is equal to volume flow rate through this pipe as well. So for this pipe also you have to write that 5 over 2 A2. Radius is A2. 4 to the power 4. What's the pressure difference? This is the higher pressure, right? If the liquid flows to this side, this is high pressure, this is low pressure. P minus P2. So here, P minus P2, right? So this, so you have P here, right? You have to just simplify these. So you can cancel these out. Then you have to just subject P. You just have to subject P. Other values are known, right? Other values are known. Then you can find just value for P. All the other values are radius, pressures, length, those are given. You just have to find the pressure at the junction. So this is the method to find the pressure at the junction, okay, which is P. Take it down. So this is the method, that is simple A. Thumbs up once you take it down. And if you have an issue, let me know, right? Okay, so that is how you find the pressure, right? That is how you find the pressure. You will clearly understand when we are doing questions. Then another type of question is B. You might want to find volume flow rate, Q. Q, right? Then write simple B, write down find in Q volume flow rate. Find in Q when P is unknown. When P is unknown. P means pressure at the junction, right? Not this one. If you want, you can write that. Find in Q volume flow rate when P is unknown. When P is unknown. Okay. Right. I'll just write the Poiseuille's equation. A to the power 4 delta P divided by eta L. So here you just have to subject delta P first. So I'll subject delta P first by cross multiplying. So what do you get? Delta P equals Q8 eta L divided by 5A4, A to the power 4. So this is delta P, right? If you follow other methods, the question is going to get complicated, right? So this is the easiest way to do this. That's why I'm giving you this. Yeah, right. Then for the first tube, just apply this. How do you do that? Delta P for the first tube. P1 minus P, right? Equals, that is the pressure difference, Q8 eta L1 divided by 5 to the power A1 4. This is the first equation. You just substituted values for this equation, right? Then for the second tube, what's the pressure difference? P minus P2. P minus P2 is equal to what? Q8 eta L2 divided by pi A2 to the power 4. This is the second equation. Then this P is unknown, right? Pressure at the junction is unknown. P means pressure at the junction. It is unknown. We are not going to find that, right? We are going to find Q. So using these two equations, you can get rid of P. What happens when you add these two? 1 plus 2. Minus P plus P cancels off. Got it? That's the advantage using this method. So what do we do? 1 plus 2. PP cancels off, then what do we get? P1 minus P2. P1 minus P2 equals Q 8 eta L1 divided by 5A1 to the power 4, 8 eta L2 divided by 5A to the power 4. Right? Then you just have to subject this Q. All the other values are given, right? You have to assume that these values are known. P1, P2, those are known in the question. You just have to find Q. So what do you get for Q? Just cross multiply everything. You get Q equals pi P1 minus P2 divided by 8 eta L1 A1 to the power 4 L2 A to the power 4, right? So these are just calculations, right? You get somewhat complicated because the equation is complicated. But there's nothing more to understand there, right? Just take this down, take everything. Let me know if you have any issue. Please thumbs up, right, if you have taken it down. Right. So no issue, right, with this one? Okay. Then write the subtopic. PL graph. PL graph. P simple L graph. L means the length of the pipe, right? PL graph. Write down below that, write since Q is same for both tubes. Q is same for both tubes. Q is same for both tubes. Tube with small simple a, tube with small simple a has a higher pressure difference, within brackets delta P, has a higher pressure difference, delta P, and tube with large simple a means radius, right? And tube with large simple a delta P is less. Delta P is less. Okay? Delta P is less. Right. So, here what I'm going to do is, throughout the pipe, right? So, this is the pipe we discussed. The pipe in series, right? Pipe system in series. Right? So here what I'm going to do is, so here the pressure is P1, pressure is P2, and at the junction pressure is P. So at each point pressure is dropping, right? So there's a pressure gradient to this side. So here let's say the pressure is like 100 Pascal. Here the pressure is like 50 Pascal. Here the pressure is 25. So from 100 to 50, pressure is dropping at each point, right? If it is 100, here it is 99. Here it is 80, 70, 60, 50. Like that, pressure is varying. Pressure is dropping to the direction of liquid flow. Pressure is dropping gradually. So you can draw a PL graph. This pressure variation along this axis is what we are drawing, right? So when you think about this equation, we are comparing this tube and this tube, right? For both tubes, we learned that Q is constant. Q is constant. Then if you think about this one, right? A to the power 4 delta P. This is what we need. Delta P divided by length. What is this? This is called pressure gradient, remember? Delta P, when you divide it by the length, it is called pressure gradient. So if we have, these are just constants, right? 5, 8, these are constants. Constants. Then we can say A to the power 4 delta P divided by length also should be a constant. Understood? When you cross multiply remaining terms, these are just constants, right? So this whole thing is equal to a constant. When you cross multiply and put it to this side, then what happens to this one? A to the power 4 delta P divided by L. This quantity, whole thing, also is a constant. Understood? When you compare these two pipes, so I have to, using this, I have to compare these two pipes. So what's the difference here? For this pipe, simple A is larger. Meaning if A is larger, pressure gradient should, what should happen to the pressure gradient? Pressure gradient should be small. So for larger radius, we need to have a less pressure gradient. Delta P divided by L. Less pressure gradient. So what do you call, remember what is gradient? Gradient is a slope, right? So if this is, gradient is 0. So now the slope is increasing. Meaning gradient is increasing, right? Gradient is increasing. Like that. Gradient is increasing. But to this side, it is a negative gradient because pressure is dropping. Okay. So at this end, pressure is P1. Here pressure is P1. So we understood, since A is higher here, A is larger here, pressure gradient is smaller here. So we have a less gradient like this. And the pressure at this point is P. Okay? Then after that what happens? Radius is small, so the pressure gradient should be large. Meaning gradient is larger. Now the slope is larger, like this. Got it? And now the pressure at this end is P2. Understood? Here, gradient here is larger. Pressure gradient is larger here. So this length is L1, this length is L2. Got it? Just draw this graph. You don't have to draw this one, right? You have already drawn this. Only draw this graph. And thumbs up once you did. If you have any issue, let me know. Yeah, sure. I'll explain the graph again, right? So this graph shows the pressure variation along the pipe. Okay. So this is the first tube, this is the second tube. So you have to consider pressure gradient along the first tube and pressure gradients along the second tube. I think with this equation you understand, right? If all these are constants, when we compare these two tubes, all these are constants, right? Eta 5/8 obviously constant, eta constant, same liquid. Q is constant because series. Then when you cross multiply that to this side, you can put a 1 letter to that. Let's say like K, simple K, which is a constant. So A to the power 4 times pressure gradient is a constant. Okay. That's why when the radius increases, pressure gradient decreases. When radius decreases, pressure gradient increases. I think you understand. In order to keep this a constant, that should happen, right? When the radius decreases, pressure gradient has to increase in order to keep this constant. That is the first thing. So here, this has a larger radius, meaning pressure gradient should be less pressure gradient. For this one, radius is small, pressure gradient should be large. Why? In order to keep this quantity a constant. Understood? So here, this length shows the first tube. Here the pressure gradient should be less. Then the pressure gradient should be larger. Got it? Here this should be less. Here the pressure gradient should be larger. Then what happens? Less gradient, larger gradient. Less gradient, larger gradient here. Understood? Yeah. So that I think everyone has drawn this graph. So that is regarding the Poiseuille's equation, right? Poiseuille's equation. We'll see some of the variations as we are doing questions, okay? After the theory part, I'll be discussing questions. Then I'll move on to Stokes equation. Write down the topic. Stokes equation. Take it down. Stokes equation. Right? Okay, so this also is a very important part. they ask many questions from Stokes equation, right? There's going to be terminal velocity, all those stuff. So they're definitely going to ask questions from these for the A levels, right? Right. So here we are talking about, so if you think about a small sphere, a small solid sphere going through a viscous surface fluid. If you think about, let's say this should be small, right? A small solid sphere going through, let's say at v velocity, going through a liquid, let's say water, or this could be air as well, right? Air also is a viscous fluid, or this could be water. If this has a v going through, at this moment velocity is v, and the radius of that, let's say simple a, and the viscous coefficient is eta. So this experiences a resistive force, right? So since anything going through a medium experiences a resistive force to the opposite side, right? Since this is moving to this side, this experiences a resistive force to the opposite side, opposite to the moving direction. So in this part, what is the Stokes equation gives us an equation for this capital F, this resistive force, right? Okay. First, take down this note. Write down viscous force within brackets capital F. Viscous force within brackets capital F acting on a small ball, that falls through a fluid, depends on the factors below. Depends on the factors below. Write down number one, viscous coefficient. Write down viscous coefficient, that is eta. Viscous coefficient eta. Second one, radius of ball, simple A. That is the second one. So these are experimentally found, right? Experimentally found. Then third one, speed of ball, simple V. In front of that, draw this. In front of these three, draw this. V, A, and eta, right? Done. Right. Below this, write a sentence. Combination between these is built using dimensional analysis. Using dimensional analysis. Combination between these is built using dimensional analysis, right? So the Poiseuille's equation we derived using dimensional analysis. So this we are going to build an equation for this also using dimensional analysis, right? So we need a combination of f in terms of these. Experimentally found these three factors. Let's say eta, we don't know the to the power which, right? To the which power. So you put eta x, then radius y, velocity z. Then you just have to find these powers, right? So first let's write an equation. Put a constant eta x ay velocity to the power z. Then just write the dimensions. So to the force, so the dimensions of both sides is same. To the force it is ml t minus 2. K is a dimensionless constant, okay? We add a dimensionless constant. So ml t minus 2, that is force. K doesn't have dimensions. What's the dimensions of viscous coefficient? As I remember, it is minus 2, right? X. This is radius. So it is L to the power y. Then you have velocity, that is L t minus 1 to the power z. Right? Then we need to get a powers when it comes to m. This side has m, that is 1. At the other side, just here, right? X. Okay, take this down and just find x, y, and z. And let me know. It is somewhat easy, right? Take this down and find x, y, and z. Then equation for L, this side 1 equals minus 2x plus y plus z. Then equation for t, time. Minus 2 equals minus 2x minus z. Yeah. X should be 1, y should be 1, z should be 1. Everything should be 1. Did you get the answer? X, when you simplify, solve this, x is 1, y is 1, z is 1. Right? So we have found the powers. Then you can substitute these in this equation. So what do you get as the equation? K eta to the power 1, a to the power 1, v to the power 1. So this is the equation. Okay, take it down. F equals k eta av. Below this equation, right? Here here k equals 6 pi, k equals 6 pi is found experimentally. K equals 6 pi is found experimentally. Here k equals 6 pi is found experimentally. So this is the final form of the equation, right? So this is how we build Stokes equation. You must remember this equation. Draw margin to that. Okay. Below this equation, write down. This is named as. This is named as Stokes equation. Sorry, Stokes law. This is named as Stokes law as below. This is named as Stokes law as below. Stokes law as below. Write down. Below that, write. When a small ball of radius simple a moves through a homogeneous large fluid body, a homogeneous large fluid body with viscous coefficient eta, resistive force acting on the ball is given by the equation above. Right. There's a theory part that is called terminal velocity. Okay. Before moving on to that, I'll just discuss some questions. Right. Take the tute. Take the viscosity tute. So in that tute, just scroll below till you get there's something like fundamentals. Do you see that? In that, try the second one. There are some multiple choice questions, right? There are multiple choice questions, and there it is fundamentals. Then try the second one and let me know the answer. If you don't remember, please refer the note, right? In the tute, you get the tute, right? Did you? Just scroll below, scroll through, and you will find multiple choice questions. Not the beginning ones, right? When you scroll through, you will find multiple choice questions. Multiple choice question. Did you find that? In that second question, let me know the answer. Second question. Which one is the answer? Yeah, fifth one, right? Fifth one. So all the units given shows viscous coefficient, unit of viscous coefficient. Yehansa, did you get the answer? Did you? Right. This is to just revise you the old stuff, right? Right. Then try third question, third one. Not only A, right? To the opposite direction, it is true for both. A is correct. A is correct. Friction depends on relative velocity. It does not, right? But viscous force depends on relative velocity. Why is that? So what is this? V1 and V2? It's the difference of velocities of layers, right? So there's a relative velocity here. But the friction on dry surfaces, on solid surfaces, it does not depend on the speed. When speed increases, friction does not increase, but the viscous force changes with velocity. Understood? So the answer should be third one, okay? A and C, yeah. That's the difference between normal friction and this friction. This friction means viscous force. It depends on the velocity. With the velocity, viscous force increases there. Then try fifth one. This is to revise you the theory parts, right? to have a clear understanding of that theories. Then try a fifth question. They are asking about not true question, right? Incorrect question. It should be incorrect question, okay? So what is the incorrect sentence? That is a correct, right? Friction, it does not depend on area. Viscous force depends on area. See this? Viscous force depends on area, but friction, it does not depend on area, right? Remember, when you are doing friction, it doesn't matter whether it is surface area is large or not. For that, it is just mu r. There's no term for area. Does not depend on area, that is true. That is correct. Yeah, fifth one, right? Friction proportional to relative velocity. It is not. Only viscous force is proportional to the velocity, right? But friction is not, right? It is just constant. It is only mu r there. Got it? Okay, then try next question, 6. Understood, right? Okay. Try 6 question. Okay, let's see. Uniform layer of a liquid with viscous coefficient eta is on a static horizontal plate. So let's say this is the liquid layer, eta. Eta is on a static horizontal plate when the top layer of liquid moves with velocity v. Top layer, they say, moves with v, and the bottom layer is at 0, right? And the bottom layer, they say, it is at a depth simple d. Force on the top layer is, in order to do this, force. So they're asking about this force, right? So eta, they should give the common area here, right? But you have to take it as capital A. There's no any other way to do that. Eta A, this velocity v, other velocity is 0, divided by this depth, simple d. Eta A v eta A v divided by simple d. So this is capital F. Got it? Yeah, first one, correct. Yeah, it's understood, right? So that is the first one. Then try 7th question. 7. Next one. Okay, 7th question. On a horizontal table, oil is applied to a thickness 1 millimeter. And the area is given, that is common area, 100 square centimeters. The speed this has to be moved is 7 centimeters per second, right? If you want, you can draw a sketch like that. Then what happens? What they ask is force eta A. Just apply this equation. You have to remember this equation, right? Eta is 1, area is 100 to the power minus 4, velocity is 7 centimeter has to be converted, right? 10 to the minus 2 divided by 1 millimeter, also convert into meters. So that is 10 to the power minus 3 meters. Then you do the simplification. So this can be easily simplified, right? This 100, 10 to the power minus 2 cancels off. This minus 4, this minus 3, minus 1, 7 times 10 to the power minus 1. So it is 0.7 Newton. Right? You have to do the simplifications simply, right? Don't complicate the simplifications. Always look for an easy way to do the simplification. Did you get the answer? Thumbs up if you have no issue, or else take this down. Right. So the second one is the answer there. Then try 8. Next question. Try next question. Draw a sketch, right? It is better to draw a sketch. Sketch. Yeah. Because you are yeah, it is. This also is a similar question, right? You just have to apply the same thing. Let me know the answer. 8th question. I'll give you a minute to solve that. Right. So 8th question. A flat surface with area. Okay, let's see. A flat surface is area 10 square centimeters. So area is 10 square centimeters. Is separated by glycerin is 1 millimeter from a large surface area. Force required and the velocity is 10 meters per second. Then eta is given as 2 kg per meter per second. So eta A, just write the equation, right? Till you get used to this. V1, V2 divided by D. So eta is 2, area is 10 to the power minus 4, velocity 10, D is 1 millimeter, minus 3. So minus 2, 20, or not 20. No, 0.2, right? 10 to the power minus 2. Eta is 2, area is 10 minus 4, velocity 10 divided by 10 to the power minus 3, 1 millimeter. Minus 2. Did you get the answer? I got 20. First one? First one, right? Your answer? Did you get the answer? Yeah, first one, right? Yeah. Yeah, Mani. Yeah. No, no, no. Just keep kilograms as kilograms, right? Kilogram is the fundamental unit, not gram, right? You have to keep it as kilograms. Then only you get newtons there. Got it? Yeah, 20 Newton is the answer. Yeah, answer, did you get the answer? First one is the answer. Okay, right. Then try ninth question. Ninth question. In the ninth question, what they ask is force on a unit surface of the uh, river bed, right? River bed means bottom of the bed. Unit area of the bottom of the bed. I mean, river. Try that. Ninth question. So here what they ask is this force, right? The top layer moves at 2 meters per second. Bottom layer is at 0. Then there's a friction acting on the river bed, which is equal to the viscous force here. Correct? Viscous force per unit area. That is what they ask. So if you write this equation, what do you get? Viscous force per unit area. What they ask is just cross multiply A to this side. They ask in this quantity. That is eta V divided by D. V2 is 0, right? Just substitute to this equation to get the answer. Understood, right? If you don't, let me know. Okay, let's see. Eta is 0.001. V is 2. D is 5. 2 divided by 5 is 0.4. 0.0004. Meaning 4 times 10 to the power minus 4. Newtons per square meter. Unit is newtons per square meter, right? Because force divided by area. This is not pressure, right? This is viscous force per unit area. Because for pressure, force should be normal. But here force is tangential, right? To the area. So this is not pressure, even though we get the same unit. Yeah, answer is second one. Correct. Then try 12th question. 12th. This 10th question, the image is not given, right? Just cut it. Put 10 and put a cross there. Just try 12th question. 12. a cube with mass 5 kilogram. Draw sketches, right? 5 kilogram and side length 10 centimeter. It's pulled by a F1 force. F1. So it moves at 15 centimeters per second. Kinetic friction coefficient, they have given mu. Kinetic means the friction acting when there's a relative motion, right, between solid surfaces. So it is given as 0.2. So this is one scenario, right? Then the same thing is done after applying a liquid layer. Thickness is given 0.3 millimeters and the viscous coefficient is 0.2 Pascal seconds. Here, in order for this to happen, the force required is F2, right? Here F1. So you just have to calculate F1 and F2 and then get the ratio. So to find F1, you just apply mu R, right? So what is R here? You know that R is equal to mg. Mg means 50 Newton. Mu is 0.2, R is 50. So what do you get? 10, right? So F1 is 10 Newton. Then you have to calculate F2. So it is eta A V divided by D. Eta is 0.2, area is it given? The area is, side length is given, so the bottom area should be 10 times 10 square centimeters. You have to convert it into meters. 10 centimeter means 0.1 meters, right? 0.1 times 0.1. Velocity is 15 centimeters. So minus 2. You have to convert into meters per second. Divide by 0.3 millimeters. 10 to the power minus 3. Right? Then 0.1. 10 to the power minus 3. Cancel with 10 to the power minus 3 here. This 15 and 0.3 can be cancelled. 0.1, 15 means 5. 5 times 0.2, 1. Then you get 0.1. So what do you get? 1 Newton. Yeah. So F1 to F2 ratio. F1 divided by F2 is 10 divided by 1, yeah? First one, yeah. Did everyone get the answer? Yeah. 10 to 1, right? So these questions, yeah. So these questions just revise you the fundamentals of the Newton's equation, right? There are complicated questions more than this, right? But these questions just to cover the fundamentals and to revise you the that Newton's equation. Okay. We'll discuss complicated questions as well at tomorrow. Class at the tomorrow we'll discuss complicated questions. These are just to cover the fundamentals, right? Right. So these were based on Newton's equation. Then we'll move on to Poiseuille's equation. Try 13th question. If you want, you can write Poiseuille's equation, then try 13th question. Give you a minute. Give you a minute to try. Right. Now listen carefully, right? So there is a special method you have to consider when you are simplifying these, doing this, right? Listen now. You have to go for proportionality methods, right? You cannot. So this is a large equation. You are not going to write this equation again and again, right? You need to get rid of stuff from this equation. So since these are MCQs, right? Then you have to consider proportionalities and ratios when you are doing a question like this. So that's the number one thing, right? Right. So clearly understand which ones that you have to compare. Right. You have two capillary tubes. So you have two tubes, right? Both tubes has the same length. Has the same length. One has a radius r, another one has a radius 2r. Both length is the same. And the pressure difference for this one is P. Pressure difference, right? For other one, pressure difference is 2P. These are not pressures, pressure differences. Delta P values. Okay? So what they ask is flow rate Q1 and Q2. So you have to compare these two tubes, these two pipes, right? When you compare these two and you have this equation, you need to get rid of constants. Constants means if there's something same for these. So these are the two cases. If something same or constant, when you compare this one and this one, then you need to get rid of that in the equation because it will cancel off, right? Not only for this one, for other MCQs, also you can apply this method. Yeah, let's see. They say length is the same, right? So get rid of length. First you have to build the proportionality. Get rid of length. Liquid also is the same. Get rid of eta. 5 over 8 is same. Get rid of 5 over 8. So what are the variables? Then this is the proportionality. Q is proportional to a to the power 4 delta P. First you have to build this proportionality. Don't write this equation too many times, right? I have seen students do that. First build this proportionality. Understood how to do that? You got rid of all the constants. Then just apply this proportional to this case and to the other case. If you apply it to this case, Q1 proportional to radius to the power 4, delta P is P. Then for the other case, Q2 proportional to 2R. 2R to the power 4, right? Pressure difference is 2P. Then you can divide in order to find the ratio. That is Q1 divided by Q2. 2R to the power 4, what is that value? 4, 8, 16, right? 16R to the power 4, 2P. P cancels off 1 over 32. Fourth one. 16 times 2, 1 over 32. Use this method, right? Otherwise, this type of a question will get complicated, right? So, once the radius is doubled, do you notice that? once the radius is doubled, hugely volume flow rate increases, right? Because r to the power 4. Okay. So the answer is fourth one. Take that down. And if you have any problem, let me know. First, you must build this one, right? This proportionality. Then deal with that. Okay, let's see. So this is the equation, right? So what are the variables? Constant pressure head, meaning delta P is constant for both. Length and diameters are the variables, right? Diameter means radius. These are the variables. Then Q is proportional to A to the power 4 divided by length. Got rid of all the terms there, right? This is the proportionality. So let's say for the first case it is Q. For the second case, let's say Q dash. Length is doubled. Length is doubled, right? So it is 2L. Diameter is halved. When diameter is halved, radius also gets halved, right? So A over 2 to the power 4. Then divide. You need to find Q dash. This A and L cancels off. I only need the numbers. 1 over 2 to the power 4 divided by 2. So this is 1 over 16 divided by 2 means 1 over 32. So what is that? Q over 32. First one, right? Got the answer? Yeah, first one. Then try next one, 15. Amani, did you understand this? Right, let's see. Here, Q r to the power 4, pressure changes and length L. Another one Q dash, radius is 4. 4 times radius increase, 4r to the power 4, pressure is 4 times, length is 4 times. So this 4 cancels off. 4 to the power 4. What's the value? 16. 16 times 4. 64. 64 times 4. What is that? 256, right? So this is factor is 256. Meaning when you divide it, 256 Q. You get 256 Q. So the fourth one is the answer. Yeah, correct. So you get that, right? Okay, so you have to go for those proportionalities. Get rid of all the constants when they're asking something like this. Right. Then try 16th. Next question. Draw a sketch. So for this question, you cannot get rid of terms, right? They are asking a certain value. It is not a proportionalities, right? There's no two cases. This is just a one case. So apply values, then find that. You cannot get rid of terms, right? For this one, you have to understand the difference. Okay, I'll give you a minute to try that. Okay, let's see. So this is an artery, right? Artery means to draw, to have a blood flow. We'll just write the equation first. Flow rate is not given, right? Flow rate is not needed. Q equals 5 over 8 a to the power 4 delta P divided by eta L. So I just wrote the equation. So here what they ask is actual delta P divided by L. Pressure difference or pressure drop for a 1 millimeter. What is that? Pressure gradient, right? What they ask is pressure drop per 1 millimeter. So what they ask is delta P divided by L. Right. So for this volume flow rate is not given, right? Get it? For volume flow rate, what can you apply? Remember this? AV, cross section times velocity. You can apply that. You applied this in the Burnley, right? For incompressible liquids. You can apply that here as well. So AV equals that one. So what is the cross section? This is a circular cross section. So this has 5a squared. That's a cross sectional area times velocity. So you can have this equation like this. A to the power 4 delta P eta L. 5 cancels off. A to the power squared cancels off. This becomes squared. Velocity is given, right? Then cross multiply 8v eta L. You don't get L here. 8v eta only divided by a squared is equal to delta P divided by L. First, you have to build this equation to find this. Then do the substitution. 8, velocity is 6. 6.6, convert everything into meters, right? 6.6 10 to the power minus 2, eta is 0.004 divided by radius, simple A is radius. Radius is 2 micro. Micro means 10 to the power minus 6 squared. So this is delta P divided by L. You get this in terms of Pascal per meter, right? Because we convert everything into meters. So this is the pressure, what they're asking you to find is pressure gradient. Okay, let's see. 2 to the power of 2 meaning 4, right? So I'll just cancel this one, 2. Here you get, no, we'll keep that. This is 6.6 to my 12, 13. Times 4. 8, 12, 5. So you get 5, 280 kilopascal. but this is per millimeter, right? If you want, you can substitute for L here, you can substitute 10 to the power minus 3 meters. So that is in millimeters. You can substitute it, then take it to the other side. You get 5280 kilopascals per millimeter. Yeah, fourth one is the answer. Yeah, correct. Yeah. Remaining questions, you can try them, right? So if you have any problem regarding any question, just mark it and you can ask me, right? Right. That is on the Poiseuille's equation. Just complete the remaining questions on Poiseuille's equation, right? Here. So tomorrow there's one more theory part that has to be completed on tomorrow. We'll do that. There's a terminal velocity, right? You can see there are many questions regarding the terminal velocity, right? So it is a key theory. I'll take some time to cover that on tomorrow's class. Then we can finalize this whole thing by tomorrow. Then you are done with the viscosity, right?